Welcome back, everyone. We're going to extend what we saw yesterday with the introduction to logarithms and see if we can't make use of, well, the new power law of logarithms. A couple of examples from yesterday. So if we had log to the base 2 of 8, one option to solve this is we understand that what we're looking for is the exponent. We're trying to find the exponent with a base of 2 that gives us the answer 8. So if we rewrite 8 as 2 cubed, of course we recognize that that's then the answer. Remember, the log is the exponent, so the question is asking us what is the exponent. Over here, log of 10,000, remembering in here it's understood we've got a base of 10. Wow! Oh, I'm using my mouse, that's dumb. Anyways, base is 10. And so the answer ends up being 4, since we could have rewritten it as x equals log of 10,000. Rearranging this into an exponent form, the base is 10. The exponent, again, the log is the exponent, so the answer to this thing is x. And then basically rewriting 10,000 as 10 to the exponent 4 gets us there. So that's the basis of what we saw. If we continue this out, then I want to look for a little bit of a patterning sort of thing that occurs. If we find log base 2, or sorry, log of 2, log of 4, log of 8, log of 16, I'm interested in seeing what we get. Doing the same thing with log 3, log 9, log 27, log 81. So what I'm going to ask you to do is pause the video here and just quickly calculate these. If you wanted to do them in Excel, if you're actually at a machine, that would be fine. If you're not, then obviously just write them out. You're going to make a little table, so leave yourself some space. Log 2 equals, log 4 equals, and then below them, log 3 equals, log 9 equals, and so on. And you can pause it there. I'll give you a second before I move on, assuming that you've paused it. And welcome back. I assume you're back. So I've pulled this up in Excel. Hopefully it's big enough that you can see it well enough. If I just take the logarithm of these values, just to sort of verify that you have the answers you're looking for, you can see they're written, a quick little equation, equals log of what's in cell A1. If I haven't said it before, Excel is, I think, one of the greatest programs in the history of mankind, and really, really nice to work with. I'll leave that for a second. So if we see what we've got here, I take log of each one. In case you're not sure, you can sort of see up here just quickly that as I move down, the logarithm that it's looking for is the one beside it in each case. And I don't think it's much of a stretch for you to notice that going from here to here, our value has doubled. From here to here, our value has tripled. From here to here, our value has quadrupled. Okay, so just an interesting little pattern that develops. If we take the same equation now over here and pull it through, it's not quite as obvious, but if we just sort of let the computer do the math for us, and let's do this. When I copy that formula down, in case you don't know, that $ just tells the computer not to adjust the 1. So now, again, kind of small for you to see probably. This E2 divided by E1. This one is E3 divided by E1. And this one is E4 divided by E1. And you see you get that same pattern. This one is double this one is triple this one's quadruple this one. Just in case you weren't sure, extend it out a little bit further and we get the exact same thing again. Whoops. This one is double this one, triple this one, and so on. So sort of the question becomes, where do these numbers 2, 3, and 4 come from? And you probably are seeing it already, but if not, so log of 9 was this value. I'm looking at the log 3 specifically here, just because I chose to. Log of 9 was 0.9424. And so if we kind of extend that out and stretch it out a little bit and take a look at it specifically, what we see is, grab my highlighter here, that log 9 is log 3 squared. Hopefully nobody has a problem with me saying that. And it ends up being, surprise, surprise, 2 times the value of log at 3. Continuing the same thing, log 27 is log 3 cubed, and it is 3 times log of 3. Log of 81, of course, is log 3 to the 4th, and it is 4 times log of 3. Okay, so what this all tells us basically is that if we had rewritten each of our originals as 3 to the exponent, whatever it was, 2, 3, 4, we could have simply taken our exponent and multiplied it by this value to find our resulting value. Okay, so sort of a little bit strange, but here's the exponent, 3 squared is 9, so there's the 2 from the squaring, times the value of log 3 gives me this. Same sort of thing with the 3 and the 4. So what does this all mean? Remembering, of course, that the log is the exponent, and remembering that when we dealt with exponents, our rule was, if we have an exponent to an exponent, we multiply the exponents to get the result. And sort of pulling these two things together, the idea that the log is the exponent, so this thing here, log of x, is an exponent, and then n, of course, is an exponent as well. What we have is the exact same thing. We have an exponent here with an exponent of n. And so in the same way that we multiplied our exponents 2 and 3 over here, we can now multiply our exponent, which is log x, by the n, and simply pull the n out to the front, work out the log x, and this becomes kind of the power law of logarithms.